How does DALL-E turn a sentence into a picture it has never seen? The secret isn't the part that draws. It's a clever way of turning images into a language. That trick is called VQ-VAE. Let's build it up piece by piece. Start with an autoencoder. An encoder squeezes an image down into a small set of numbers, a latent code. A decoder takes that code and rebuilds the image. The squeeze in the middle forces the network to keep only what truly matters and throw away the noise. But a normal autoencoder stores continuous numbers, an endless range of fuzzy values. VQ-VAE makes one powerful change. Instead of storing a blur, it stores a word, a choice from a fixed, finite list of codes. Continuous becomes discrete. That list is called the codebook, a learned dictionary of vectors. Think of it as a palette the decoder has been trained to understand. Each entry is a little pattern the model knows how to draw. The whole image will be described using only these. Here is the heart of it, quantization. The encoder produces a continuous vector. We search the codebook for the single nearest entry, throw the original away, and keep that entry instead. All we remember is its index, its number in the codebook. That index is a token. A picture has become a grid of integers. So the full VQ-VAE looks like this. An image enters the encoder and becomes a grid of vectors. Each vector snaps to its nearest code, giving a grid of token indices. The decoder reads those tokens and paints the image back. Compress, quantize, reconstruct. How does it learn good codes? 3 forces. A reconstruction loss so the rebuild matches the original. A codebook loss, pulling the codes toward the encoder. And a commitment loss, keeping the encoder loyal. One catch. The snapping step isn't differentiable, so the straight-through estimator simply copies the gradients across the gap. Now, DALL-E, it is really 2 models. Stage 1 is this discrete autoencoder, which DALL-E calls a DVE, and its only job is to learn a vocabulary of image tokens. Stage 2 is a transformer that learns to actually write in that vocabulary. The numbers are striking. A 256 by 256 image is compressed into a 32 by 32 grid, just 1024 tokens, drawn from a codebook of 8192 possible values. That's hundreds of times fewer symbols than raw pixels, finally short enough for a transformer to handle. And that is the whole point. The transformer reads one long stream. First the text tokens describing the caption, then the image tokens. 256 words plus 1024 image tokens, modeled together, exactly like a language model predicting the next word, except now the words include pieces of pictures. So generation is simple. You give it text. The transformer predicts the image tokens one at a time, conditioned on your prompt. The decoder turns that grid back into pixels. DALL-E even samples many candidates and uses clip to pick the best match. An astronaut riding a horse, never photographed but easily spoken. And that's the idea. Quantization turns an image into discrete tokens. Tokens turn an image into a language. And once it is a language, a transformer can write it from nothing but a sentence. That is VQ-VAE, the discrete heart of DALL-E.